So I went into depth on a little bit more about the wet vent and the volume of water coming out of the laboratory dropping a short distance into the 3-inch pipe, which that 3-inch pipe for the toilet is right there. Okay. The amount of water going into the 2-inch is not going to displace or actually cause movement in the toilet itself. That's the whole idea of volume in the pipe with wet venting. Now, your grade on your pipe is important for the concept or the engineering understanding of lift and drag, or what plumbers call self-scouring, coming from an engineer explaining the lift and drag concept. The water drops, or depending on the nature of what is dropping through the air, okay, depending on the friction that is, and dropping down, the formula for anything falling through gravitational field on Earth is approximately 32 feet per second, or 9 meters per second. Okay, but you still have a gravitational effect, gravity flow in your pipe with a 2% grade. That 2% grade is what's the term I'm looking for? I'm going to have to redo this. To make most efficient the lift and drag point of view of what is lift and drag is water flowing past or onto a solid, and the volume of water helps lift and drag the solid along. Now, the most efficient percent, which is 2% here on the pipe of grade, or a 1/4 inch per foot, up to 3-inch is required at a quarter inch per foot grade. That's the most efficient for the lift and drag. Once you get to 4-inch, the volume of water that is a 4-inch is sized for a certain amount of fixture units, as is described. Fixture units. Okay? That is that lab is 1 fixture unit. A shower is 2 fixture units. There's certain aspects of, okay, well, is it a commercial fixture? Is it in a residential fixture? Is it a residential fixture? Is it a commercial fixture? There's differences in the amount of water. Is it a gravity flow toilet, or is it a mechanical flush toilet? Okay, that you see in your commercial buildings, your gravity flush toilet, which the toilet itself, the urinals are supplied with 3/4 inch. The toilets are supplied with 1 inch to the flushometer. Okay, 1-inch pipe. Okay, so there's a lot more volume. So depending on your fixture unit, they size. A residential application is different than a commercial application. It's a little bit, quite a bit more in depth, truthfully. It's engineering standards. Okay, so the lift and drag is what's trying to be accomplished at the most efficient drop to carry to cause the lift and drag to be at its most efficient is what the engineering standard has come to with, because of the amount of water flowing through. Because with lift and drag, you only want the pipe to be so full, which is a third of the volume of the pipe, to maintain that lift and drag at a certain degree of drop, or certain percentage of drop. So with your 4-inch piece of pipe, it carries a lot more water at one time at that third. Okay, so your fixture units, the pipe is rated to a certain amount of fixture units, and that is in the horizontal and vertical. Okay, so you have 32 fixture units on 3-inch in the horizontal, and I forget. I'd have to look in my book. Most of the time you do it so much you forget stuff like that. But there are certain things that you get used to doing. You can only do certain things. Like, for instance, you can only put 3 toilets on a 3-inch piece of pipe before you have to convert. If on the 4th toilet, even in a residential application, you have to go to 4-inch because of the engineering standards suggesting. So you've got on a horizontal 2-inch, you have 8-inch fixture units. On a horizontal 1.5 inch, you have 2 fixture units that you can carry horizontally. Okay, vertically, you can carry 16 fixture units in the vertical, or on 2-inch, and I forget the 3-inch, and it's 256 on the 4-inch in the horizontal. So there's different conditions of measuring and volumes of water with solid waste in your pipe, and what happens in your pipe, and the density of the air in the pipe. And the list just goes on and on the physics of the design and the attitude of the pipe. Okay, so plumbers don't have to know all that good stuff. They don't have to have the math to figure all that good stuff out, the physics and the calculus and so on and so forth, to get to the point where they understand this stuff. All they have to understand is the engineer is stated in code that is adopted by the state that the best design for the mechanical system is such as they have written in their code, and 1/4 inch per foot of grade is one of those standards for everything up to 4-inch, which then 4-inch becomes an inch, or an eighth of an inch per foot per grade. It's the volume of water in that lower portion of the pipe that matters, that gives you the lift and drag, the most efficient point of lifting drag in the pipe. So, I don't explain things well or articulate well sometimes, and many times, because I forget anymore the terminology. It just passes my brain by, I guess. I'm getting old. But what the heck. If you can understand approximately what I'm saying and why the plumbing systems are designed the way they are, and why you don't do certain things, as I've seen some of these people with their circuit vent designs. Now, some states do allow things like circuit vents, which is venting more than one fixture. But for instance, if you have a circuit vent, say for instance, you're venting the toilet, okay, and you're venting a tub and a toilet and everything, and your vent pipe off your toilet is going to also be a vent for your tub, and then down a little ways you have another vent that there's normally two vents in what is called a circuit vent system. You have one upstream and one downstream a little ways, and you have to design it accordingly so you don't get those conditions of pressure that could push and pull on the water in the trap. And that's what happens with water flowing through a pipe. You have pressure buildup with the air in the pipe that flows to low pressure zones, and there's movement of air in the pipe as the water flows through. So the air will move up and down in a pipe with water flowing through that pipe at, depending on if the pipe is clear full, you don't have any air in it. Or you can, but you don't want, in a drain system, you don't want a gravity drain system, you don't want the pipe full. Now, this sump pump, this pipe will be full all the way up to here, all the way up to where it drops in, because the pump is pushing a volume of water all the way up to the 3-inch and down in. And then that's full of water, but that is what it is, and I've got that sucker so crooked. But it doesn't leak, so what the hell. But anyway, a lot more going into, and you see these people doing their groundwork, okay, which is under the concrete, okay, and they're circuit venting under their concrete, or they're doing different things, and their state or municipality will allow it maybe, or their municipality says they can do certain things that in other states you have uniform plumbing code or international code, and these codes are adopted, whereas some states adopt certain things that you can do, which is whatever, you still have, from state to state, you still have the same physics when it comes to how water and air react as water flows down in a gravity system through the pipe. So, you'll see someone in North Carolina or South Carolina or Wisconsin or Minnesota suggesting what their local municipal code will allow, doing their little video, whereas, say, in Idaho or Washington State or California, you ain't going to get away with it. So my advice to you is to follow what your state or your municipality allows, or just use the Uniform Plumbing Code, because for the most part, the Uniform Plumbing Code is the higher standard. Your international code allows 10 feet on trap arms for toilets. Uniform Plumbing Code is only 6 feet. You can only go 6 feet on the trap arm from where the toilet drops the water into the pipe to where the vent and branch drain is connected, is only 6 feet. Okay, 3 inches, 6 feet, 2 inches, 5 feet, 1.25 inches is 42 inches. So, yeah, there's definitely some differences from state to state. So you want to be aware of it. If you ever even have a tendency to look around and ever see this video, which I've posted it, or I will have posted it, is what it is. You got to find out what your municipality and what your state allows, and understanding the mechanical conditions, or the physics in the pipe that are going on, and the mechanical engineering standard that's developed is, if you're going to do it yourself, and as far as a plumber is concerned, as far as I'm concerned, doing it yourself, I care less. Because most people are really busy making a living as far as what they do to make a living, and why would they, unless they have the time, why would they want to have to set time aside to fix something or do something that they can hire done. And, so as a plumber, I could care less if people do it themselves. Because there's a lot of people out there that I don't want to do it myself. There's things I don't want to do myself. I mean, I might be able to do it, but I don't really want to because it takes time out of my day of things that are priority for me. Simple as that.